Let's go ahead. Last time we were doing electro and gravity. Let's do a few more questions and we'll go ahead to capacitors and current. Let's get this. So there's three graphs: Vx graph, voltage versus X graph, voltage versus Y graph, and voltage versus Z graph. Find the electric field in the region. This is a different question. If you have a dipole in a non-uniform electric field, then which of the following four options are right? And which of the following four options are possible? So three different questions. Shall other scans on? Let's see. Hope you guys remember the electric field is nothing but minus dou V by dou X I cap minus dou V by dou Y j cap minus dou V by dou Z k cap. So basically you have to take the slopes. So here what is the slope? Here dou V by dou X will be minus 1. Dou V by dou Y will be tan 30. So 1 by root 3. Dou V by dou Z will be minus 1 by root 3. With a minus sign, substitute that and you'll get the field. The answer is I cap minus 1 by root 3 j cap plus 1 by root 3 k cap. Clear? What about the next one? Which of the following are possible? All are possible. Now people mistake this with something else. If E is 0, remember E and V ka relation, E is not V by R, E is dV by dr. So if E is 0, then dV has to be 0. This is right. Right? If E is not 0, then dV will not be 0. So don't get confused between dV and V. Both are two different things. I hope you're getting it. E0, V0 is fine. When you have no charge, that is possible. Can you tell me a situation where you have E0 but V not 0? Inside a hollow spherical shell. Inside a hollow spherical shell, field is 0 but potential is not 0. Where will be V0 but E not 0? If you take a plus q and minus q, at the center potential is 0 but the field is not 0. Are you getting it? Because potential is a scalar quantity, so you can play around like this. What about this thing? Dipole in a uniform electric field, non-uniform electric field. So if you have a dipole in a non-uniform electric field, I think I should write this thing as dipole in a presence of a point charge. That would be better. We have done this in the class notes. Exact same question. Then what will happen? Can torque be 0? The torque can be zero. There is one possibility. See, when you take a charge q here, and if you look at the field line, the field lines will be radial. So if you put your dipole along the field line, so if P bar is parallel to E bar, then torque is zero. Getting it? But force can never be zero. Why? Now ask yourself, if you say force is zero, if F is zero, this implies, right, force on the charge Q due to dipole is also zero, Newton's third law. That means we should keep it. That means, therefore, the charge Q is at the null point of a dipole. But does dipole have a null point? Is there any point where the field due to a dipole is zero? But dipoles will never have a null point. Dipoles do not have a null point. You do not have a point where the electric field is zero. Therefore, force can never be zero. Are you clear with that? You can argue like that also. So you can take all the cases where torque is zero, force is not zero. So basically B and D. Is that clear, everyone? Because if you say force on the dipole is zero, that means the force on the charge is zero. If the force on the charge is zero, that means dipole is giving a zero electric field at that point. There is no point in the space where dipole will give a zero field. Are you clear with this? You can argue like that. Or another way to argue, in order to get zero force, what should happen? You should have field equal magnitude, opposite direction. If you're on the same line, you'll get opposite direction, but magnitude won't be same. If you take like this equidistant, you will get same magnitude, but the directions won't be same. You can satisfy only one of them. You can't get same magnitude and opposite directions. This thing you can do, the 4-star system. Let's do this thing anyways. 4 particles, binary star system, remember? These are 4 stars rotating about a center of mass. Side A, find the time period. A particle is projected vertically with speed root 2 gm by 2 bar. Find the h max. At what distance from the surface the gravity is g by 2? G apparent. How do we do this? So these other 4 stars are going to attract it. So let this be force F. Force F is gm square by a square. This also will be force F, and this will be, the distance is a root 2. So this force will be F by 2. Agreed? And since it is going in a circle, it will experience a centrifugal force, which is m omega square r, where r will be a by root 2. Getting it? This will be the center here. The radius of the circle will be a by root 2. So you're done. So the resultant force will be F by 2 plus 2F cos 45 is equal to m omega square a by root 2. From here you get omega and then you get time period. These binary systems are very important. Right? I think don't remember the year, but there is one year where in that same exam they asked 2 questions on binary star. Like I said, the paper is not being set by a person, right? Computer is randomly choosing questions. That's the reason questions are repeating a lot. How to find H max here? Don't use u square by 2g. I hope, right? G is not constant. So as it goes here, somewhere it will stop here. Let this be H. This is state 2, this is state 1. Conservation of energy. Potential energy initially minus gmm by r. Initial kinetic energy half mu square. Finally, potential energy minus gmm by r plus h. Kinetic energy 0 because that's your H max. From here you get H star value. What about G apparent? There are 2 points actually. There is one inside and there is one outside. This is height h and this is depth d. Hope you remember the formula for G apparent. G apparent will be G by 1 plus h by r whole square. This is the G apparent for height. For depth, the formula is G into 1 minus d by r. Do you remember the third formula, variation of gravity with rotation? G minus omega square r cos square theta. Cos square tha wo, and where theta is the latitude angle, the co-latitude. So there will be 2 points where you get this answer. Be careful. And there will be one more formula, 1 minus 2h by r. Don't use this. This is an approximate formula only for small heights. 50 kilometer, 10 kilometer. Here gravity is becoming half. It's a big variation. You can't use an approximate formula. Clear with that? Clear with this? Let's get this thing. We have a tunnel. A particle is released from the top. At the bottom of the tunnel, it collides with the surface and E is equal to half. After collision, what is the maximum height it will go? You dig a tunnel along the diameter. At the center, it is sealed though. So if you drop the particle from the top, it collides and bounces back. Find the maximum distance from the center after collision. I hope you remember, whenever you collide in a head-on, your speed becomes EU. If the same problem had been asked like this, na, where gravity was uniform, if you drop the particle from height h and E is equal to half, hits the ground with speed u, you bounces back with speed u by 2. You actually go only to h by 2 ka height, h by 4. Isn't it? Next time you'll go to h by 16 and so on. You can't use this thing here. That is valid when gravity is constant. Here G is changing. So how do we do this? So let's find the speed at the center. How can you find the speed at the center? Either you can use SHM or let's conserve energy simply. State 1, state 2. Energy at the top, potential energy minus gmm by r. Kinetic energy 0. Potential at the center. What is the potential at the center of a solid sphere? Minus 3 gm by 2r. Be careful, not a 0. Kinetic energy half mu square. Solve this, you will end up with u is equal to root over 2 gm by r. Gm by r. You're going to hit this thing with this speed. So if you hit with speed u, you bounce back with eu. So your speed is actually half of root gm by r. So after bouncing, let's say it comes down and then goes up again with u by 2. It stops somewhere here at a height. Let's call it x. Now we again conserve energy. Half m u by 2 whole square plus potential energy minus 3 gmm by 2r. Now the headache is this, the formula minus gm by 2r cube into 3r square minus x square into m. Remember, that is a potential ka formula inside. It's not minus gm by r. You take the value there and substitute. So yeah, m cancels off. Half also goes off. That would be u square 1 by 4 gm by r minus 3 gm by r minus gm by r square 3r square minus x square. Gm also goes off everywhere. 1r also goes off here. 1 by 4 minus 3 is equal to minus 1 by r 3r square minus x square. I think we need one more r somewhere. Name this thing. Did I miss an r extra? Yeah, r square. I think you're done. You'll get it from here. How much is this? Minus 4311 by 4. R square is 3r square minus x square. 4312 minus 1 r by 2. It will go to half of the height. If you use that uniform gravity, wala answer would have been r by 4. So be careful with that. You can't use that uniform gravity ka result. Clear? Collisions, gravitation. You can play around like this. Little lengthy, but check your calculations. This is another good one. We have 3 orbits. First orbit is circular. Second and third orbit are elliptical. All have same masses. Arrange them in the order of time period and energy. So 3 orbits of 3 different satellites are given. I have overlapped all of them, but technically the picture would be something like this. In case you are thinking, how is this possible? So for the first case, the star is at the center. In the second case, star is somewhere here. The star is not at the same place for all the 3 orbits. In this case, the star is somewhere here. You're getting it? The focus is different. But all of them will have same semi-major axis. That's what they're trying to show there. So you have 3 orbits of same semi-major axis. Then arrange them in the order of time period and energy. This is a result you should remember. Answer is same. Anyone remember the energy ka formula actually? Energy of an elliptical orbit minus g mm by 2a, the length of the major axis. Iska proof na we did in gravitation ka notes. You can check it out. That's a pretty good one. Advanced problem tha wo. There, if you remember, this is the same question. Total energy and the time period is independent of minor axis. This was the proof which we did. This question, you can check it out. But it's a pretty good result. Should remember, elliptical orbit ka that energy is minus gm by 2a. For a circular orbit, we know how to derive, but yeah. And the time period will be t is equal to 2 pi root over gm a power 3 by 2, where m is the mass of the star. Clear? That's a good result. Most people will think they see the ellipse and they get scared what to do. This is another good one. We have a comet or a satellite, going around the sun. This distance is r and that distance is v. What is the time to compare the time taken to go from DAB and BCD? What is work done by gravity from A to C, positive, negative, 0, and find the aerial velocity. Hope everyone has filled up your JEE ka form. Don't delay it anymore. Time is running out. There are some people who are still chillingly aram, they're trying to fill it out. So how to do this thing? Do you guys remember Kepler's second law? The comet covers equal areas in equal intervals of time. Now be careful here. When it looks like equal areas, it is not. The area is always measured from the focus. So when you say DAB, you're talking about this area. It is not measured from the center of the ellipse. It is measured from the focus. So area of DAB is greater than area of BCD. So therefore, this will take more time. What is work done by gravity from A to C? What is work done by all forces? Change in kinetic energy. That will be half m bc square minus half m ba square. We can clearly see the farther the comet, the slower it will go. So this is negative. What is aerial velocity ka formula? Aerial velocity dA by dt is nothing but angular momentum by 2m. The Kepler's second law is actually another form of law of conservation of angular momentum. याद है? वो CET question था. Kepler's second law is another form of what? They gave momentum, energy, angular momentum. It's another form of law of conservation of angular momentum. Since the aerial velocity is constant, L bar is also constant. So that is the proof. And what is angular momentum? MVR. That's the aerial velocity formula, L by 2m. Clear with this? And why angular momentum is constant? Because torque about the sun is 0. Why torque is 0? The force is always passing through the sun. The gravitational force always passes through the sun. Therefore, torque about the sun is 0. Therefore, angular momentum about the sun is constant. Clear with that? How to find a VA? In this case, you can find, you can conserve energy and angular momentum conservation, isn't it?
And distance is not given, no?
Find out, no? Big deal. You have two variables, two equations. Kya problem hai? You just didn't want to use energy.
The distance between sun and A is not given, no?
Or find out, na, God.
What?
Find it, na?
Sir, how do you find that?
सोच के बता मुझे क्लास एंडिंग तक.
Okay.
तुझे सब दे देंगे तो you will just use momentum and get the angular momentum and get the answer happily. Let's get these two. A comet is coming from very far. The distance is a. क्या था क्लास में? Find u minimum to avoid collision. As it gets closer and closer, if the speed is less, there is a chance you will go and hit the planet like this. If you throw very fast, you will go like this. So there is a minimum velocity where you will just graze the planet and go. Ansh, did you figure out? No. I told you something, remember a common statement I keep saying. If something is not going in a circle and something is not going in a straight line, there's only one way we can do problems. What? Ansh, yeah, the statement. We have to use conservation of energy and conservation of momentum, isn't it? So, अभी बताओ अभी क्या कर सकते हो? Let the distance be x. Energy conserve करो, angular momentum conserve करो. Two equations, two variables. Now you still think we can't find? Happens. Yep. Let's get this thing. दोनों class notes का questions था. Again, I'm telling you, mains they're not going to ask you something out of the world, new questions. That is not the purpose of mains. You should know every standard model that is there. Out of the 25 questions, at least 15 questions you must have seen before. You should cover so much variety. So then exam में 15 questions will take only half an hour to solve. Then remaining half an hour, you can fight and do another 8-9 questions. And if you can finish your physics paper in like 55 minutes, chemistry paper, if you can finish in 40 minutes, then max you'll have around 1 hour 15 minutes. And if you're doing max more than 1 hour 15 minutes, trust me, you are doing a big goof up. You will get slaughtered. So always be careful when you're writing practice papers. I'm seeing some of you are doing that. Especially when you write previous year papers now, physics and chemistry paper is easy. People are finishing off in 1.5 hours, physics and chemistry, and they're doing max 1.5 hours. So how to do the 24th one? Again, same thing. If you're not going in a straight line, if you're not going in a circle, conserve energy, conserve angular momentum. State 1, state 2. Initial angular momentum, MUA, you're calculating about which point? The center. Torque about the center of the planet is 0. Therefore, angular momentum is conserved about the center of the planet. Why torque 0? The force always passes through the center. So MUA. Remember, angular momentum is MU, perpendicular distance. So it really doesn't matter how far the comet is. What matters is only the perpendicular distance. MUA is equal to MVR. This is equation 1. Energy conservation, potential energy is 0. Kinetic energy half mv square minus gmm by r. Potential energy plus half mv square. Two equations, two unknowns solved. You'll get the answer. B का आंसर क्या था? For a satellite, which of the following is the potential energy, kinetic energy, total energy? This thing came recently in modern physics also. Remember Bohr's theory? Mein? Kinetic energy, potential energy, and total energy of an electron in an orbit. So these three graphs, the red line, the blue, and the green, and the black, which is total, which is kinetic, which is potential. What is potential energy? Minus gmm by r. Kinetic energy plus gmm by 2r. Total energy minus gmm by 2r. So kinetic has to be positive. So the red one is kinetic energy. Compared to this thing, this will be total energy, the green one. Potential energy is more negative. The black one is the potential energy. Clear? Easy one, but yeah, people do goof up. Check it out. Clear with that? Potential energy is more negative. You have two planets, rho and r, 2 rho and 2 r. Find the ratio of escape velocity and the gravity on the surface. Hope you guys remember the formula for V escape. What is V escape? Root 2 gm by r. But here densities are given. So this is proportional to root over mass. That is rho into 4 by 3 pi r cube. So that is rho into r square. What about G? Gm by r square. So this is proportional to rho into r. So first case escape velocity v1 by v2 will be rho r square by root over 2 rho 2r whole square 1 by 2 root 2. G1 by G2 will be 1 by 4. Okay.
सर
Hmm.
प्रीवियस क्वेश्चन के ग्राफ में सर वो उल्टा होगा कि
मतलब
पोटेंशियल एनर्जी और नेगेटिव है तो वो तो नीचे होना चाहिए ना?
Yeah, you're right. I did a mistake. That was a mistake. I was seeing something else. Right. Total energy था वो. That is a mistake, everyone. Correction है वो. Check कर लेना. I was just seeing the minus and actually this number is bigger. It's a bigger negative number. It will go more away from the origin. See, even I did a mistake. I will get -1. There. Clear with this. Next thing, let's go ahead with capacitors. We have two parallel plates. Let's say this charge is Q1, this charge is Q2, capacitance is C. There is a switch. Find the initial potential difference. When switch is open. Find heat produced when switch is closed. So two parallel plates, capacitance C. One plate में charges Q1, one plate में charges Q2. This comes from the definition Q is equal to CV. What is Q exactly? Q is not the total charge on the capacitor. Q is not the charge on the positive plate. Q is something else. Right, Ahna. नहीं इधर या that is wrong. See, in the formula Q is equal to CV, Q is the charge on the inner surface of the positive plate. So when you write Q is equal to CV, this Q is the charge on the inner surface. So you need to know how will the charge distribute. Hope you remember, we saw this in Gauss law. Outside the charges will be Q1 plus Q2 by 2. The inside will be Q1 minus Q2 by 2. Minus of Q1 minus Q2 by 2. I'm assuming Q1 is greater. So that will be the positive plate. So Q1 minus Q2 by 2 is equal to C into V. That's your potential difference. Because logically, if you think about this, the reason you're getting electric field between the plates is because of these charges only, right? The electric field between the plates is because of the charges on the inner surface. So that is this thing. Now, when you close the switch, what will happen? The inner charges will vanish. The moment you close the switch, this will become 0, this will become 0. Outside charges will remain same. So what was your initial energy? The initial energy of the capacitor is Q1 minus Q2 by 2 whole square by 2C. The final energy of the capacitor is 0. So what is the heat produced? Initial energy minus final energy. All that energy which is there in the between the plates vanished. Clear with this? So be careful that Q is not the charge on the capacitor. That meaning if you say like that, you'll get confused what is C exactly. So C is the Q is the charge on the inner surface of the plate. We have a capacitor C. Then what we did, case 1, the battery is removed. Case 2, battery is still present. So initially the battery is connected to the capacitor. In one case, you removed the battery. In another case, you kept the battery. Then what you did, you introduced a dielectric slab. Then what happens to the new charge on the capacitor, new capacitance, the new voltage, the new electric field, force between the plates. So initially, if the force between the plates is F, then what is the new force between the plates? If the initial electric field is E, what is the new electric field? Force between the plates, what is the energy density? What is the energy stored and what is the energy density? And in 7 questions, I can ask you find the ratio of initial by final, case 1 and case 2. Hope you guys remember this model. So you are comparing with this case and you are comparing with the case when you have dumped a dielectric slab inside. So what is the charge? If the initial charge was Q, what was the charge in case 1 and case 2? If initial capacitor was C, what is the capacitance in the case 1, case 2, and so on? Get this. This is a good one. Hope everyone has resolved the speed test paper 1. That's important. You have to resolve the whole paper again, or else there's no point in writing the paper. And I hope you realize paper was easy only, right? Kuch bhi nahi tha aisa, like, something out of the world. It's only a matter of speed. So how do we do this thing? First thing, what will happen with the capacitance? It doesn't matter whether you have battery or no battery, capacitance will become Kc, Kc. Start with the capacitance. In the first case, you removed the battery, so charge will remain same. In the second case, you kept the battery, the voltage will remain same. Isn't it? If the battery is present, voltage will remain same. If you remove the battery, charge will remain same. Charge cannot change. Now start solving from there. So what is the voltage? Q by C. So this becomes 1 by K times. This charge becomes K times. Electric field is potential difference by distance. So here it will remain same. Here potential difference became 1 by K. This becomes 1 by K times. Force between the plates. This is important, everyone. Force between the plates is Q square by 2A epsilon. Not epsilon m, epsilon only. Because remember, the plate ka charges will be Qn minus Q. The force between the plates does not depend on the dielectric slab, isn't it? The dielectric slab is neutral. It will not exert any force on the plates. So there people have that confusion a bit, so be careful. Let's say if you have a parallel plates and if you have a dielectric slab, at this point, if the field is E, meaning just outside the plate, if the field is E here, inside the field becomes E by K. And I hope you remember this result here. If this is sigma, this is minus sigma I, this is plus sigma I, and this is minus sigma. If you see, a dielectric slab is still neutral. The dielectric slab will not exert any force on the plate. Net is 0. Anyone remember the result of sigma I? This itself is a good question. What is the induced charge on the dielectric? Sigma into 1 minus 1 by K. That is the induced charge on the dielectric slab. For conductors, when K becomes infinity, you'll get sigma is equal to sigma. So opposite thing. So the force between the plates, since the charge remained same, the force will remain same. This will become K square times. What about the energy? I can use two formulas there. I can use either Q square by 2C or half CV square. So if I use Q square by 2C, this becomes 1 by K times. Half CV square, this becomes K times. What is energy density? Now it will depend on half epsilon E square. Because energy density, that is a field in the region. So that will be half epsilon M only. So here this will become K times, and the electric field has become 1 by K times. So 1 by K square times. So 1 by K. Here this thing becomes field is same. So this is K times. Clear with this? You can also argue like this. What is energy density? Energy per unit volume. Volume is same. Energy became 1 by K times. Clear with this? And same thing here, the slabs ka thing. I hope you remember the result. Let me ask you like this. So if you have two parallel plates connected by a battery, square plates, side A, D is the distance between the plates, and let's say A is much greater than D, so you can treat them as big plates. And let's say surface tension is S and contact angle is theta. And let's say you keep this thing just above a liquid. This is a dielectric liquid. Dielectric constant K, surface tension S basically. So what will happen? The liquid will start rising between the plates. Find the height. There I mixed up two different things. Find the height of the liquid raised between plates. Do you guys remember the force on a dielectric slab? वो formula you need to remember. That is the main question I wanted to ask. I just added something more. The force on a dielectric slab is what? A epsilon V by 2D into K minus 1. Remember this? Minus n आएगा, basically an attractive force, if you remember. And this force is constant. So if you put a dielectric slab between the plates and leave it, what kind of motion will it oscillate? Periodic motion. SHM नहीं है. Because for SHM, force should be proportional to x. This is the result you should remember. Direct questions you will get on this thing based on the result. I think then let's do combine both of them. So when the liquid is rising up, the liquid will actually look something like this. If you guys remember, the surface now will look like a stretcher. If you put a patient in a stretcher, how will that surface look like? It will look something like a bent surface. No, again, if you're looking into my screen, it looks like this, isn't it? It looks like this. The surface will be bent, no? Like this. Able to see this thing? The surface will look like this. It's bent. And how will the surface tension act here? The surface tension will act on this line here, this way, which is surface tension S into the side is A at an angle, and this will act like this at an angle. This is a contact angle theta, that is a contact angle theta. So the net upward force will be 2 SA cos theta. Plus you also have the force on the dielectric slab. That must be equal to mg. So 2 SA cos theta plus A epsilon V square by 2D into K minus 1 is equal to density, the side, which is, so this liquid, we are ignoring that meniscus ka thing, A into H into D into G. You get H ka value from here. Clear with this? Hope you guys remember both the questions, one in surface tension, one in dielectric slab. We just mixed it up. Clear with this? Find capacitance of the system before and after closing the switch. The terminals of the battery is this, A and B. Find CAB before and after closing switch. I can actually put a charge and we did this question last time if you remember. I said find the heat produced when the inner shell is grounded. This is a good one. If I ground, that capacitance changes for the system. What's the catch? How many capacitors are there? There are two capacitors. That's the first thing you need to realize. So there is one capacitor between the plates. This is C1. There is one capacitor C2 between the infinity. The infinity is your third shell. Okay? Now when the switch is open, look at this. When the switch is open, so infinity, right? You'll put the terminals, let's say A, B, and infinity. So you have the capacitor C1 between A and B. So battery is between these two. And you have one capacitor between B and infinity that is just hanging in air, right? That is just hanging in air. So this is useless. So the answer is C1. And you know how to calculate C1, C2, right? I will leave it to you that C1, C2 will be 4 pi epsilon r 2r by 2r minus r. C2 will be 4 pi epsilon 2r. But when you close the switch, same story, A, B, infinity, whose potential is 0, ground is also 0. Now we are putting a capacitor between A and B, and the other capacitor, now see when you ground the inner shell, this has become grounded, isn't it? Point A became grounded. And this capacitor is here, C2. And this is also 0. So basically you can say this is also grounded. So your circuit has become like this. This is A and this is B, C1 and C2. They both are parallel, isn't it? Meaning I can just close the circuit like this. So what is the potential difference? VB minus 0. What is the potential difference? VB minus 0. So both the capacitors are in parallel. Are you clear what I did? The moment you close the switch, suddenly this guy potential becomes 0. The infinity is 0. So C1 and C2 ka potential difference becomes same. The capacitors become parallel. Are you clear with this? They have same potential difference. So C equivalent will be C1 plus C2. Clear? So be careful with the grounding thing. There are actually two capacitors. One is between the outer shell and infinity. One is between this. If you don't ground it, the outer shell is useless. So it will be just hanging in air. These are some really important questions. The fifth one. Normally they'll mains level, generally they'll ask you two capacitors, but let's do for three. Let's say this charge is plus Q, minus Q, and this charge is minus 3Q, and this charge is plus 3Q, and this is empty. Find the final charges when the switch is closed. how to do these kind of questions. Assume charge Q is going from any one capacitor. It doesn't matter. You can start from any one. So I will assume charge Q is going from here. So if the charge Q goes from here, then this guy will become Q minus 3Q. You're getting, you can just assume Q is continuously flowing through this. Q is flowing, so this will become Q. The other plates I'm not drawing, and Q will come back again. So remember, once you say Q is starting from here, whichever plate you touch, you have to add plus Q, and you have to come back again. Are you clear with this distribution? Then you're done. Apply Kirchhoff's loop law inside. I'll start from here. So apply Kirchhoff's loop law. You're going from negative to positive plate, the potential will rise, Q by C. Then you're going, let's assume this is positive, the signs will take care. Q minus 3Q by 2C, then minus Q by C equal to 0. Done, you'll get the answer from here. C goes off Q minus Q by 2 plus 3Q by 2 minus Q. 5Q by 2 is equal to 3Q by 2. Q is equal to 5Q by 3. This is the charge which went through the capacitor. So the final charges will be substituted there, you'll get the answers. Are you clear with this? Any doubts on this? This is an important model. Q went na shit, right? It's Q minus Q. This guy will be Q minus Q. This will be 5Q by 2, so Q will be capital Q. Now, right? You assumed Q went away, na? So that charge should decrease to Q minus Q. Clear with this? These models are important. Huh? The same thing, let me ask you how they'll frame it in mains level. Mein. And they will say like this, there are two capacitors, 2 microfarad, 100 volt. Then they'll say another capacitor, 3 microfarad, 50 volt, connected in reverse polarity. Find the new voltage. Meaning positive is connected to negative, negative is connected to positive plate. Find the new voltage, the new potential difference. Meaning this is plus, minus, this is plus, this is minus. These two are connected and these two are connected. Same polarity meaning plus plus connected, minus minus connected. Find the new potential difference. You guys remember I gave you a general result for this. V will be C1 V1 minus C2 V2 by C1 plus C2. Yeah, the result. You should check it out. Meaning you can do it normally. ये था result याद है? Charge to voltage V1, charge to voltage V2. Same polarity, reverse polarity. Clear with this? You can do this and finish off faster. So, or you can calculate literally. Now this is plus, minus, minus, plus. Then it will be little work. So this will be Q1 minus Q1, this will be minus Q2, and this is plus Q2. Same story, we'll assume Q is flowing here and then write Kirchhoff's law and solve. All clear with this? Similar one. Let's say we have a capacitance, we have a battery this time. We have one more capacitance. Let's say this is V. This is minus 3 CV and this is plus 3 CV. This is 0 and 0. Find the final charges and the heat produced when switch is closed. This time you have two capacitors and a battery. C1, V1, C2, V2. They're connected in reverse polarity, right? So that will be minus. Same polarity will be plus. Now, first thing, are these two capacitors in series? No, remember that's a blunder. Just because they're side by side, don't say they're in series. Series का definition क्या था? They should be in the same branch and have same charge. Clear? Just because you're side by side, don't assume that. Only if they're empty, you can take that assumption. So then how do we handle this? Let charge Q flow from the battery. So let charge Q flow from the battery. Then this charge will become Q minus 3 CV. Then this will become Q. Apply Kirchhoff's law. You're going through the battery, V minus Q minus 3 CV by C minus Q by C is equal to 0. We get CV plus 3 CV minus Q. We get Q is equal to 2 CV. That means if you look at the final charges, this will be 2 CV, this will be CV minus CV. This will be Q minus 3 CV. Now this will be minus CV, CV. This will be 2 CV. This is minus 2 CV, where the charges are not same. They're not in series. Be careful with that. Most common mistake, they think it is in series just because they're side by side. And what about the heat produced? This is important. The heat produced will be whatever is the initial energy in the capacitors, initial energy plus work done by batteries. Battery also did some work here. That is the reason you need that small q value minus U final. Work done by the battery is the charge that is flowing through the battery into voltage. Clear with this? So work done by battery will be 2 CV square. Initial energy you can find Q square by 2C. Final energy you can find from the capacitors. Finish it off. All clear with this? So that this is how you can play. Matlab, you can put a capacitor, you can put 3 capacitors, you can put a capacitor and a battery also. These questions are important. Clear? Then so we have 5 parallel plates. Area is A for all of them, and B is the distance between them. Find C equivalent. A better question would be find the charge on plate 1, 2, 3, 4, 5. That would be a much deadlier question, but let's find C equivalent for now. That will be even at an advanced level, it's a decent question. Find the charge on plate 2, find the charge on plate 3, find the charge on the upside of the plate 3, find the charge on the downside of the fourth plate. You can play like that. But let's get this thing. C equivalent is still an easy one though. Next thing is circuit. Circuits will, whatever you learn here, the idea will be same in current, but yeah, series parallel is reverse. Hope you remember nodal analysis. So let this be A. So this plate also will be A. Let this be B. This plate also will be B. Let this be C. Then this plate also will be C because they're connected by a wire. And this is D. So even though there are 5 plates, in reality there are only 4 terminals. So A and B will be always in the corner. Then take C and then take D. So the first capacitor is between plate 1 and 2, that is between A and C. Second capacitor is between C and D. Third capacitor, see what is the capacitor here? The space between the plates. So there are 4 capacitors. Between 3 and 4, that is D and B. And the last thing is between B and C. Can you solve this? Okay, na series parallel. Clear. Take a break. Come back by 9:45. 5 minutes.
Actually, I have some doubts related to current capacitors. So, is it okay if I send it to you now? Send it to you on some
Which doubts?
I have some PYQs related doubts. So, is it okay if I send it?
PYQs, you have detailed solutions now, right? Still you didn't understand? So PYQs, go through the solutions. They are given, right? Solutions are detailed for PYQs. If you still didn't understand, then send it to me. That's fine. But always have a look at the solutions because the PYQs already have detail. There's no point. But check out the solution. You're still confused, send it to me. जाके करना है तो इनका काम, उसका कुछ इश्यू नहीं है. There. Let's get this. Each segment is resistance R. So what to do here? So how many different terminals are there? You can say this is C. You can clearly see these two are in series, isn't it? This one are in series. So that is R. R, that will become 2R, 2R, and this thing are in parallel. So this whole triangle here, right? That whole triangle will be 2R and R, 2R by 3. So if you just redraw the whole stuff, we have a resistance. We have a resistance. Similarly, this whole triangle is also 2R by 3. because this is R and R, 2R, and that are in parallel. And that 2R by 3 and 2R by 3 are in series. Actually, ये पे calculation हो रहा है ना? This is 2R by 3. This is 2R by 3. Basically, this became B. And there's one between them, R and R. You can solve this now. Clear? How that became 2R by 3. What about C? नहीं, एक और resistor है यहाँ पे. There is one between these two also, ना? This one. Still you can solve, right? These two are in series and these are in parallel. Now it will be done. So how much will that be? That will become 4R by 3 and R. This whole setup is 4R by 3 into R by 4R by 3 plus 1, 4R by 7. That 4R by 7 and R are in series, so that will be 11R by 7. 11R by 7 and R. 11R by 18. Yeah? What about the C1? We have a hemispherical network. Resistance of the wires is this. Find the equivalent between O and P. Now look at here. If you're starting from O and ending at P, point A, B, C, D are identical, isn't it? So when you go from O to P, if you go from ODP or OAP or OBP, they all are identical. Means you can remove all the resistors between A, B, C, D. So your circuit actually becomes like this. So this is O, like this. That is your P. Meaning it will look like this. You can just remove that. So I'll keep it simple here. This is O. This is P. So you can basically make one resistor here. One resistor here like this. Like this. There'll be two resistors. R1, R2, R1, R2, R1, R2, R1, R2. R1 is this resistor, which will be rho into length, which is pi r by 2. The other resistor is R2, which is this length, which is rho into R, because rho is the resistance per unit length. Is that clear, everyone? So all resistors between A, B, C, D can be removed. They're equipotential, so there'll be nothing between them. And the resistances are not equal. That AP ka resistance and OA ka resistance are not equal. It depends on the length. So be careful. Don't write them as R and R. Hope you remember this. Find CA, RAB. Each segment is a resistance. It's a 3 into 3 grid. Each segment is resistance R. Find resistance between A and B. Yeah, you can. Why किया ना, Puruja? You can do this. Basically वही हो गया ना, all four will become parallel. Hope you guys remember bisector symmetry and axial symmetry. Let's see. Hope you remember how to do this thing. There are two symmetries here. First thing is your bisector symmetry. What is bisector symmetry? The two terminals are on either side of the line. So when you have this symmetry, what happens? You can open the nodes along the line of symmetry. You should definitely check out the nodes. We have the same question there. So along this line, you can remove the node. So this guy opens up and this guy opens up. And you can join them like this. The second symmetry, axial symmetry. What is axial symmetry? When the line passes through the terminals. In this case, you can fold the circuit about the axial symmetry. Because up and down are looking identical, they both are parallel. You can fold it like a waffle. So when you fold this, all resistors, right, become parallel to each other. So everything becomes R by 2. So this is 1. This is how it looks. And now all resistances are R by 2. So R by 2, R by 2. If it is capacitors, no, they'll become double. Be careful, huh? Because when you keep capacitors in parallel, they double, the C1 plus C2. When you keep resistors, it become half. Then you can solve this. This is R by 2, R by 2, R by 2. That becomes 2R. R by 2, R, R. This is R. R and R are in parallel. That will be R by 2. R by 2, R by 2, 3R by 2. So it will look like this. R by 2, 3R by 2. This is 2R and this is R by 2. That you can solve this. I'll leave it to you. Clear with this. If you simplify, this is how it looks. Symmetries, check it out. In the circuit given, find the potential at point P. P is this point. So that the current through the battery of 4 volt is 0. So there is no current in this 4 volt battery, and it is they're asking the potential at point P. Okay, 32 R by 11 K. Anyone got this? Didn't solve. So, okay. I actually got 32 R by 11. So someone else got it to fine. 13 by 7, it seems. Okay. What to do with this guy? So this thing you can solve. So r by 2, r by 2, r, and that is how much? Yeah, you can calculate. Let's get this. Let's keep going. Okay, people are saying 13 r by 7 for the previous one, so you can verify. I'm focused on giving more questions, so sometimes if I mess up the calculations, correct me. I am trying to go as many questions as possible. Because I feel in an hour, if you sit and study on your own, you will do at least 15 to 20 questions. If you don't do at least 12 to 15 questions in the class, it's a waste of your time. But I think we are doing 1 hour at least 15 questions. Answer for this. Find the potential at P so that the current through the 4 volt is 0. You need to draw something here. Remember, this is 1 ampere. This is also 1 ampere. That is 4 volt. So I can actually directly go from here to here. See, if I go like this, that will be what? 10 minus 1, 3. So this point will be 7 volt, isn't it? This point will be 7 volts. If this is 7, that will 7 minus 4. This is 3 volt. Agreed? Because that's a battery, na? The potential difference must be 7. And I want to find the potential at a point P. Okay. Now, if that is 3, then what will be the current in this branch? That will be 4 minus 5 minus 4i1. You reached 3. That would be 4i1 is equal to minus 4. The i1 is equal to minus 1 ampere. So current is actually going 1 ampere in that direction. 4 minus 5 minus 4i1 must be 3. So that will be, no, wait, that is not minus 4. What did I do? That is 4i1. 3 comes this side. 7 minus 4, 2. i1 is equal to half ampere. No? Similarly, if I take this current is I2, then this will be 5 minus 3 minus I2 into 1. You reach 7. So I2 will be 5 minus 3, 2 minus 7 minus 5 ampere. Is that right? Or am I messing up calculations for some reason today? 5 minus 3. Yeah, looks right. That means in this branch, current 5 ampere is going this way. We got the current in the branches. So we got in this branch, current is 5 ampere. In this branch, current is half ampere. And 1 ampere is coming from the top. So that will give you current in this branch how much? 1 plus half, 3 by 2. And 5 is going from here, 1 is coming from here. So this current must be 4 ampere. If that is 4 and if that is 3 by 2 is coming, the balance current will be coming from here. 4 minus 3 by 2, 8 minus 3, that will be 5 by 2 ampere. Is that making sense? You need to find the current in the branches. Potential right behind 4 must be minus 1. Yeah, that is okay, and that we don't need anyway. I1 is coming minus 1 here. Are these values right? Currents are right? Anyone?
So I1 should be negative 1, no?
Mm,
The first equation that you wrote.
I wrote 4 minus 5 minus 4i1 is equal to 3. If 3 comes here, 4, 3, 7 minus 5, 2. Did I write the equation wrong? Yeah?
So like we should add
तो
ऐसा
4 minus 8 हो जाएगा ना
-1
फिर
-3 हो जाएगा -1
4 volt, you're starting from 4, you went through the battery minus 5, then it is minus 4i1, then you reached 3, na? I think I'm doing something else. I think I'm
The
hungry, I guess.
calculation error. 4
4 minus
the
3 minus 1
calculation error in the
minus.
first equation.
minus 4 हो जाएगा.
My head is not working. ठीक है.
Minus
Should have had
4
my
हो जाएगा.
dinner actually. ठीक है. Let's do it आराम से. Yeah, minus 1 ampere. So current is going 1 ampere here. That actually makes your life easy. If that is 1 ampere, so ये branch में current 0 ampere था. And if that is 5 ampere, then this branch is 4 ampere, and this branch is also 4 ampere. Clear with that? Then you can write the potential difference at point P. You can go from here to here. Vp minus 4 into 4 minus 4 into 2, and then you reach 7 there. 16 plus 8. 31. Clear with that? So from P, come towards this point here. So that will be 4 ampere here and 4 ampere there. But got the process here. You need to find the current in the branches, and then we have to do this. Slightly more complex. Not an easy question. Mains level तो नहीं है, but it's a good one. They can at least ask you the current in the branches. That itself is a good question. Clear with this? Junction law and that. So there was one more question like this recently Ansh asked. So good one. Find the current in the ammeter. Ideal ammeter. Huh? So ammeter has no resistance. How do you handle this thing? See. Remember nodal analysis? Let this be 0. If this is 0, this is 0 because it is ideal. That means this is minus 6. If that is minus 6, then this is minus 4. Then this will be 0. 0 or minus 8? Minus 8. Then this will be plus 2. Then the current in this branch will be potential difference is 2 and 10 ohms. So this current will be 1 by 5 ampere. This current will go from here to here. This will be 4 ampere. This current also will flow this way. This will be 1 ampere. And this current will also go this way. 3 ampere. All this current must be coming from somewhere, na? Here. Making sense? So I must be equal to 3 plus 1 plus 4 minus 1 by 5. Clear with that? Hope you guys remember the node analysis thing. So if you remember, there was one very nice question we did in current. Yeah. Anyone remembers? This was a very good one. So the middle branches have current 1 ampere. The question is find the potential difference between A and B. The current in the AB branch. This branch may want the current. Try. Let's get this. All resistances are equal. R. So how do we do this? Start from somewhere. Start from here. This is 0. For convenience, let's take R is equal to 1 ohm. It won't matter. So if that is 0, current 1 ampere is coming. This must be plus 1 volt. This must be minus 1. This must be minus 1. Current always goes from higher to lower voltage. If this is minus 1 and this is plus 1, that means the potential difference is 2 ampere. So current flows from plus 1 to minus 1. So this is 2 ampere. This is also 2 ampere. And this is 1 ampere. That means from this branch, you're getting 5 ampere ka current. If that is 5 ampere, and this must be plus 6. Making sense? And if that is plus 6, this is minus 1. Same argument you can do. This is 2 ampere. This is 1 ampere. So this will be 5 ampere. So this guy will be plus 6. This guy will be minus 6. If that is, wait, this is minus 6. This is 1 volt. If this is plus 6 and this is minus 6, the potential difference is 12. So this branch may have 12 ampere ka current, this branch may 12 ampere ka current, and this branch may 5 ampere ka current. This branch may get 29 ampere. It's all junction law. There's nothing there. I mean, you just have to keep doing it. It looks easy now because you have done it once. but it's a really good one. Clicky nahi hota hai, and people don't expect 29. Do you guys remember this? We have done this before. So make sure to go through this again. It's a pretty good one. There is one more like this. I hope this you remember, I'm sure. The maze. This current is I2 and this current is I1. Find I1 minus I2. Yeah, people do remember. So what is the catch in this thing? You have to find a path where that branch is the only there and remaining all are batteries. So this is R, this two are R by 2 and this is R. So you can treat that whole thing as one resistor. Go like this. There, we got a loop now. If you go in that loop, that is the only resistor and remaining all are batteries. So this is plus V, this is plus V, and there, you're done. So that will be 2V minus I2 into 5R by 2. You get I2 from here. Similarly for I1, go like this, follow the same path, but this time go this way. Or you can go this way also, it would have still worked. So for the green one, you have plus V, plus V, plus V, minus V, plus V, minus V. So that is also 2V only. You got I1 ka value. Do you guys remember the maze? So in these kind of questions, the catch is this. You have to find a path where you have to go through that resistor, but remaining all should be batteries. Because if you touch one more resistor, what will happen? You'll get a new current, I2, whose value we don't know, right? Current in each branch. But as long as you pass through the batteries, it doesn't matter how much current is passing through the batteries. I hope you're clear with that. Find C equivalent. This is not a Wheatstone bridge. I could have messed up more by giving 3C. But still there's a symmetry, yeah? Diagonal symmetry. Yeah, you won't get such a good answer. So how do we start this? Let this be 0, let this be V. Now if you see, there is a diagonal symmetry, meaning this and this side will be same. So if you assume this is X, what is the meaning of diagonal symmetry? If charge Q flows here, then by symmetry Q should flow here, meaning here and here same thing will happen. So ask yourself this thing, if this charge and this charge are same, that means this potential difference and this potential difference must be same, because it is the same capacitor and the same charge. So if that is X, then this will be V minus X. Are you clear with that? If I had given you this is 3C, then you're gone. Then you have to take it as Y and then solve. Because there's a diagonal symmetry, luckily you'll still get one variable less. So you're done. Then what to do? Assume charge Q is flowing like this. Let this be Q1. Right? And let this be Q2 and let this be Q3. We know the total charge flowing into a node is always 0. So Q1 plus Q2, 3 plus 0. What is Q1? Higher minus lower potential, V minus X into C. Remember, charge is C into V. For Q2, the potential difference is 2C into 0 minus X. I'm assuming charge is coming from 0 plus C into V minus X is equal to 0. C goes off, we get V minus X minus 2X plus V minus 2X is equal to 0. We get 2V is equal to 5X. We get X is equal to 2V by 5. Again, symmetry, if this is Q2, then this is also Q2. That means the total charge flowing through the capacitor Q must be battery is Q1 plus Q2. The Q1 ka value is V minus X, which is 2V by 5. 3CV by 5, and the Q2 ka value is minus 4CV by 5. Yeah, the numbers are coming good only. So Q1 plus Q2 will be minus CV by 5. Something I goofed up.
Plus 4C.
No, Q2 should be in the other direction actually. I should assume Q2 is flowing that way, because if I assume Q2 is coming this way, symmetry it should go that way. That will be Q1 minus Q2. I could have taken charges going in any direction, it wouldn't have mattered. So Q1, Q2 aa gaya, then I think you're done, right? Why am I getting such good numbers? 8CV by 5. So Q by V is equal to 8C by 5. I'm sure this is wrong. 437, yeah, what kind of calculations I'm doing? There, people. So if you don't have your dinner and you solve questions, your head doesn't work. So make sure to eat food on time. Play with this. Let's see one more. These are good ones. Hope you remember. Let's get this. Hope you guys remember these things. What is the first thing? I is equal to NEAVD. So you're keeping the current in another wire of half the radius. So this is proportional to R square and we drift. So if the radius becomes half, this becomes 1/4, then the drift velocity becomes double, the current becomes half. What about this thing? This is the standard result. You have to remember standard statement that resistivity of a semiconductor decreases with increase of temperature. True or false? If you increase the temperature, resistance of conductors will increase and semiconductors will decrease. Reason? Remember avalanche breakdown, Zener breakdown. There we did a discussion little. You will release more number of free electrons, so the n will increase in that, even though there is more this thing. Conducting the rate of collision between the free electrons and the ions increase with the increase of temperature. Both are right. That's not the explanation though. What about this one?
Why should be false, right? Because resistivity is asked. Resistivity is a property of the medium.
Which one?
By the statement.
Resistivity. Yeah, rho will decreases. True, no?
It is independent of, it's the property of material, right? So it shouldn't change.
So rho is what actually? Rho depends, right? It depends on temperature. When you say property of a material changes with temperature. Because think of like this. See, what do you mean by property of the material? So when you increase the temperature, the electrons will get more thermal kinetic energy, right? So they escape from the orbits and you'll create more free electrons. So that you're actually messing up the internal property, right? So if you say like that, then density should not depend on temperature because it's an internal property. But when you heat up a body, density decreases, isn't it? So that way, so if you mess up your temperature, your internal properties can change. What about this one, everyone? An insulating pipe of cross-section area A contains an electrolyte which has two types of ions. This you have to be careful, huh? The positive and the negative charges will travel in the opposite directions. But both will have current in the same direction because the flow of positive charge is called as current. This will be number of ions is n, charge is double, area, velocity is v by 4. This is n, e, a, v. So be careful, they will add up, don't subtract them. So what is the answer? 3 n, e, a, v2. Because in a solution, when you see the positive and the negative charges will go in the opposite direction, isn't it? But the current will flow in the same direction. There is one more really good question on this. Where is that? This one. This will actually cover up a lot of theoretical stuff on that. The 11th is a really good one. Let's see. The first was easy. It's like equation of continuity. Smaller the area, faster the electrons will go. So Vp is greater than Vq. 11th. Let's get that one. See, a metallic conductor of irregular cross-section is shown in the figure. Potential differences applied across it. So what will remain same? Whatever current enters, same current will come out. So the current at the cross-section of P equals to the current at cross-section Q. True. Current entering is equal to current leaving. The electric field at intensity at P is less than Q. Now if you remember, current ka definition J is equal to sigma E. And J is nothing but current by area. Sigma is constant, I is constant. So E is proportional to 1 by area. So more area, less electric field. So Q will have more electric field than P. True. B is also right. What about the heat produced? Heat generated per unit time heat per second is nothing but I square R. Now, resistance at a small segment. So if you take a small cross section dx, the resistance will be I square rho dx by area of cross section. So heat is also proportional to 1 by area. Means thinner cross sections will produce more heat per second compared to the thicker cross sections. This is the reason, let's say if you have a bulb and inside the bulb you have a filament, and for some reason, let's say the filament has become little thin at one place. So these thinner spots will generate more heat per second. So they get heated up more. So they will melt more. They'll become more thin. So they'll generate even more heat, and eventually the thin point will break. You're getting it? So if you take a non-uniform wire and put it in a bulb, and if you heat it, the thinner cross section will become more thinner, and eventually it will crack. So C is also right. The number of electrons crossing per unit area at P is less than that of Q. Now again, current is same. That means same number of electrons are passing through the entire thing, but he's asking per unit area. Getting it? The total number of electrons crossing per second is same, but if you divide by area, again it will change. So D is also right. All four are right. Are you clear with that? So here this thing, they have same electrons, but if you divide by area, AP, and you have same electrons, and divide by area at AQ, P is greater. So yeah. Clear with this? Yeah, that's few of this. So Friday when we catch up again, we'll continue from here. We will do more questions on this. We'll do few more circuits. We will see RC circuits and all that stuff. And especially we are going to do that moving coil galvanometer. Yeah, the figure of merit. Anyone remembers this thing? Half deflection galvanometer, half deflection method. Go through that. You forgot everything, I remember. So go through all that stuff. Potentiometer will not be doing. It's not there in the portion, but advanced scale it is there. So we will see that later on. Potentiometer is removed from the mains portion. And maybe we'll do one or two problems just to keep a grip on it. Right? So we will do instruments. Instruments is quite important. Okay, with that, we'll wrap up for the day. Right? And we'll catch up again on Friday, same time. So we'll continue from here. So like I keep saying, keep writing papers and keep solving your material. Finish your PYQs as soon as you can. Okay, with that, we'll wrap up for the day. So any doubts, anything else, please stay back and ask, or else you're free to leave.